Today we'd like to talk about solving logarithmic equations. It's really not all that bad. We'll take a look at it here. We have two separate situations, one where we have more than one log, one where we have just one log, and really we're going to involve two different strategies. One of them will be to do a rewrite into exponential notation. Rewrite in exponential notation. And then solve as we did any of our exponential equations. The other one would be if we have more than one log, if we have two logs, and that's all we have, we can set the insides equal to each other. And you'll see that the insides equal to each other, and then solve from there. Here we have two logarithms, both of them log base 2. And that's all we have. Well, all we're going to do is realize that if these are the same everywhere else, these insides have to be the same as well. So we can go and take and make these two insides the same. Now we no longer have a logarithmic equation. We have a good old-fashioned equation where we're going to simply get all of our x's on one side, get everything else onto the other side, divide both sides by 2, and that will leave us with a 2 for our answer. Really not all that exciting. We could actually do this one by making it into one logarithm. Maybe we'll come back and look at that in just a minute. We'll see how we're doing. Here we have a couple of examples where there are only one logarithm. Well, if we take and do an exponential rewrite, in other words, remember this means that 3 to the 5th is equal to x. If we go ahead and write that like that, we've solved for x. If we know that 3 to the 5th is 243, then we have what we needed. All right, we've solved for x. Likewise, over here we have one logarithm as well. My suggestion is that we get it alone so that we can deal with the logarithm on its own. And if we do that, we can get log base 3 of 5 to equal a 4. And now I'm missing my x. Let's put our x back in there. He's going to be kind of useful. From there, I can see that I have a 3 to the 4th power is the same as a 5x, or 81 is the same as a 5x, and x, although it's an ugly fraction, it's just 81/5. Really not that bad. Now you might be asking, well, Mr. Lorenz, could we have solved the last problem that way? Well, let's leave that one alone for just a little bit longer. Maybe we'll come back to it. This is actually our last example, and it's going to get into a couple of different ideas. First of all, we have two logarithms here, but that's not all we have. We also have this one over here. So I cannot just set them equal to each other and just look at the insides. That won't work very well, especially with both of them on the same side and being added together. However, we do have some logarithm properties that we know. So we can take this x and this x minus 2, because they were two logarithms that were getting added together, and we can multiply those inside the logarithm. And I'm going to take the time to go ahead and make that into an x squared minus a 2x equal to that 1. And now we're at a point where we have one logarithm. We can do this as a rewrite. So I can say 8 to the 1st power is the same as x squared minus 2x. Or, since I have a quadratic, we'll use our quadratic rules for solving and simply set it equal to 0, and then perhaps do a little factoring. Once I factor this guy, I start to realize that x is 4 or negative 2. Now, one thing that you need to realize is just because you get these as answers doesn't mean that they are answers. You need to go back and plug these guys in to your original function to make sure that they would be okay. Now, the fact that x is a negative number is not a problem in and of itself. The fact that we are taking the log of x by itself is a problem. One thing that we maybe not have not mentioned as of yet is that you cannot take a log of negative numbers. So no logs of negative numbers. All right, you can't do it. All right, and if you think about what a logarithm is, this is how we understand our logarithms. This is our base. A base to any exponent isn't going to all of a sudden make it negative. So taking a log of a negative number doesn't really make all that much sense. As long as we're taking with positive bases, and that's really what we're going to define our logs to be, at least at this point in time. And we don't want to get into anything else. Now, if that's the case, in this particular example, we're looking at a point in time where x or x minus 2 cannot be negative. Well, as long as x is positive, then as long as x minus 2 is positive, then x would be positive as well. But definitely a negative 2 is not going to work, and I'm going to be left with x equals 4. Log base 8 of 4 and log base 8 of 4 minus 2 will still work together. Those ones will be okay. Now, let's go back to our first example here. One question might be, well, Mr. Lorenz, could we have used this idea back there? Could we have used some of those properties? Well, let's back up a few slides and see how that would have worked. It probably wouldn't have been the most ideal thing, given the fact that the other way worked so nicely, but could we have done this and subtracted log base 2 of 2x plus 5 from both sides and set it equal to 0? And the answer is yes. We would have ended up with a log base 2 of a 4x plus a 1 over a 2x plus a 5 equals a 0. And then we could have rewritten this in exponential form. 2 to the 0 equals 4x plus 1 over a 2x plus 5. Now, right here is where you start to realize that we really have done this in an overkill kind of manner. If we get to this point, the next step would be probably to cross multiply. So let's make this into a fraction over here, and you'll see that we end up with a 2x plus a 5 equals a 4x plus a 1. Not all that, no, that's not solved, keep in mind, but not all that different from where we could have started this problem in the first place. It's kind of nice to look at it and see that it can be solved in more than one way. I don't think I would ever go about solving this one in this nature. But to see that it works kind of affirms our properties and makes us feel a little bit more comfortable that they really do indeed work. All right, I hope that this helps you better understand how to solve equations that involve logarithms. I don't think they should be too bad. They shouldn't be something that scares us too much. Just kind of go right into it and see what you can do. If you have any questions, please ask me.